last. It's been from third to yesterday it's like 10th, and today is kind of 11th October. We're almost at the end of the Navratri celebrations, and it's like tomorrow is the last session that we are hosting. So the main focus of this event is to encourage more women, and making sure like giving them a kind of an inspiration through all these things, and same time giving them knowledge about the cloud native projects, and promote more women into the CNCF community. So yeah, that's the main intention, because this Navaratri is kind of a woman related festival, which is resemblance of feminine energy. So this sounds like a best opportunity for us to make the series go live everywhere. So yeah, so coming to our speaker, Ashwini has been working as a lead consultant with Introspect, and she has been involved in DevOps based community, and she has done, I think, open source side. She has been part of that community as well, and she's been a speaker, and she's doing a lot of work there. So I'm happy to introduce Ashwini, and looking forward to listen to your thoughts and suggestions. Ashwini, thank you so much for speaking us today. Yeah.
Oh yeah, thanks, Bhaji. That was really nice introduction. Actually, you covered most of what I planned to say about myself. Yeah. Okay. Sure. So let me get started, right? So yeah, hi folks. I'm Ashwini Manoj. I
Uh,
work at
Nancy, thank you so much for joining us.
yes. Hi Mansi. Nice to see you here. Right. So yes, coming to me, right? I'm Ashwini Manoj. I'm a lead consultant at Introspec, and mainly Introspec works with both infrastructure as well as backend consulting. Uh, and so I'm here to talk about service mesh for enhanced resilience and reliability. Right. So before I get started, let me set some context. Right. Um, like service mesh to a beginner, it would sound like a cool concept maybe, or something to be scared of maybe, right? But before that, let me come to what it's trying to solve, right? So in the microservices world, or in a hybrid cloud environment, now that we have multiple cloud providers to choose from, you could have a self-hosted service talking to something on your cloud, right? Or you could have it could be a very complex architecture where there are multiple microservices talking to each other, right? Now, how do you facilitate the communication between these services, right? And how do you ensure there is security and reliability when these communication happens? What happens if one of your downstream API fails, right? uh, you do not want to cascade that failures across your services. You would want uh, a circuit breaker or a retry logic to save you from having mishaps like that, right? So how do you ensure that, let's say you have around uh, 50 microservices, and it might sound a lot to people, but I have worked in projects where there were at minimum 80 microservices at least running, all had different uh, purposes. It's spread across domains, right? If I talk about payment domain, you might come up with 10 microservices if you really needed it, and when you have a complex business, it can span across different domains, each requiring its own set of microservices, right? Now, how do you ensure you keep your timeouts or configurations related to circuit breaking, it could be, or any other communication related config updated, right? uh, that becomes a hard problem usually. And uh, what service mesh tries to do is it brings in a layer where you can abstract away these configuration into that layer. That what that means is your application does not have to set retries or um, any knowledge of these aspects that service mesh takes away, right? Sounds cool, right? Again, we'll come to whether it is actually required, but this is where the USP of service mesh comes in, right? So then let's go to what exactly is a mesh, right? So honestly, it's a pattern that specifies how service to service communication can happen within a network, right? You can use it to talk from, say, ingress network as such. That is when you have an external service invoking your internal service, but the main focus of a service mesh is to facilitate the communication within a network, right? And usually how that happens is through a sidecar proxy, right? And yeah, what is a sidecar? Right? Sidecar proxy specifically, if you see this diagram, right? I mean, this image, you can see there is a helper who can sit with the person actually driving. So while somebody is actually controlling the bike, there is somebody else probably helping that person somehow, right? And that's what, just like what a sidecar is, this proxy is the one who communicates with rest of the services, right? And like I mentioned, this is how the network logic is taken away from the application logic. So your main container would run your application logic, while your sidecar proxy would be the one taking care of your network logic, right? Yeah, so these are some of the popular service meshes available. They have their own implementation and nuances to it, but mainly they all provide the same functions that a service mesh does. Maybe there are some things missing, and we'll talk more about it in detail, right? uh, Today I'm going to talk about Istio, mainly because I've had experience working with it, but all the concepts could be replicated with any of the other service mesh you see here. So coming back to service mesh, right? Like, what does it look like, right? And like I said, there is a sidecar proxy that runs, and we'll call that the data plane. So this is where all the data gets transmitted or intercepted to make some, and so the sidecar proxy makes a decision what to do with it. A control plane exists to configure your sidecar proxies. Configure in the sense, what should your routing rules be, right? We'll talk about this in the next slide actually. So yeah, coming to control plane, right? Um what do you use it for? Like I mentioned, you would configure your sidecar proxies. You want somebody who you can talk to. This could be through a CLI, usually. So with, in case of Istio, there is Istio CTL that's available. You can configure your routing policies. You can configure your security configurations like authentication, authorization. You set these rules here, right? You can enable the MTLS communication between services. You can, and this control plane is where telemetry is collected from your data plane, right? And this is also what enables service discovery. Let's come to the data plane, and that's the layer that enforces your routing policy. Your sidecar proxy now knows, when it sees a route, where it should forward your request to, right? It is what intercepts all your inbound, outbound traffic from the application, and it also ensures that there is secure communication with other services. It sends collects the telemetry data and sends it to your control plane, and this is where your circuit breaker retries and load balancing logic are applied. So yeah, coming to Istio, this is the actual architecture of Istio. So at control player plane, you have something called IstioD, and at the data plane, you have your proxy running, sidecar proxy, which is Envoy. Yeah, and Istio has other modes that it runs in. I'm not going to talk about ambient mode. I'm just specifically talking about the sidecar proxy. Right. Yes. So coming to STOD, which is at the control plane, right? Uh, like I said, it helps with service discovery, configuring your traffic. It has certificate authority available that can help with certificate management. And what it basically does is convert your routing rules into NY proxy configuration. This is what ensures that you're conforming to the your NY proxy is what is ensuring the communication is going through, right? You can also introduce service identity based authentication and authorization. There's JOT based authentication authorization you could make use of, right? Um, and yeah, uh, NY proxy sits at the data plane, right? And this is where it's deployed as a sidecar proxy, and this is where all the policies get uh, introduced. I mean, enforced. So, yeah. Any questions till now? Any thoughts? Okay, I think I will go forward then. Right.
So if anyone have any question, feel free to ask. Probably we can answer all the questions. You can just post it in chat section. We'll answer all the questions at the end of the talk. Uh, Thank you.
Yeah, sure. So yeah, I'll continue for now. So before I show something practical, let's just get familiar with Istio, right? So Istio has custom resources defined, which you specify to get whatever routing logic that you want to implement, right? So virtual service is one of them. What it does is it uh, you know it's abstracting away the knowledge of who the client is talking to. What that means is client just knows there's uh, a virtual service in between. It doesn't even know it's a virtual service. It just calls this person, and this person uh, routes the request to the actual workload. So it could be based on the routing rules you have defined, and we'll see more about that. And it facilitates customization of routing rules, right? And we'll see how fine grained we can make it in some time, right? And you can have more than one virtual service based on your needs, and that again depends on your use case and your architecture, right? So this is what a virtual service looks like. How you configure it, right? It's pretty simple in the sense of understanding it. So let's say you have a reviews service running. So you what you want to do is route to it, right? And what do you want to route? You say that your gateway decides what is routed to this service, and uh, for now, whatever is routed to this particular host, if it has header end user JSON, then you route it to V2 version of reviews. And if you have anything else, then any other API request that doesn't have this header, it will default to the V3 version of reviews. Right? We'll see in detail about what destination is and what subsets are, but just to give you a glimpse of what a virtual service is. Coming to destination rule, this specifies if you have multiple versions of a service running. It could be that you are re-architecting your service. Maybe it's going from a monolith to microservice, and you want to now distinguish between the both, right? You don't want to make a it's you don't want to wait until all of your functions or operations are taken into the new service before you start routing traffic, right? You'll go step by step. If you have five things to implement, maybe you start routing one API to your new service once that is ready, while the other four still remain with your old service, right? So in this case, let's say V1 and V2 are two versions that are running. what your destination rule says is that once my virtual service has decided where to route to, that your routing policy has taken effect, how should my workload be selected, right? So in this case, when your service receives uh, API or a request, right? It we are specifying that use the traffic policy. You could say like the load balancing that takes place. By default, it is I believe least request. What that means is that if you have say three pods running, the service with the least request is given the request first, right? This way it ensures that no service is overloaded, right? So in this case we can choose random. So it randomly chooses between your workload, or you can say round robin in this case. So if you see, we are saying version 1 remains as is, version 3 remains as is, but with version 2 we'll do a round robin load balancing, right? And yeah, coming to gateway, this is meant for ingress traffic. So you, if you want to um, you know um, hit your APIs that are within an internal network, you would use something like a gateway to make that happen. Istio has its gateway implemented. I think it's been out in the last 2 years, but yes, you can have, yeah, you can use the Kubernetes API gateway. Istio is going in the route of making that default in the future. It's not yet happened, but yeah, for now you could use this. Right. Now, let's talk about what exactly Istio is, not just Istio, but what does a service mesh actually help you with, right? One of the main things I mentioned is traffic management, right? So it's not just about routing requests to your service from your external entities, but it's also how does communication. The main part is how does communication happen between your services, right? Um, in this case, let's say you introduce order service. You already have an order service which talks to your payments service, right? Now when I say your application logic can be abstracted away from your resilience configuration, what I mean, or your communication network, is that let's say you bring in version 2 of payments. Maybe it was a monolith and you're breaking it down to smaller services because it's a requirement from your business, right? um, what happens to order service? You Order service would need to know, uh, oh, there is a new service, I have to route to it. Now like I said, you might have, you're still migrating your service, so you would have some functions in your payments version 2, some things remain with payments version 1. How do you split between them, right? Do you want to take the pain of it at order service? Not really, right? And you could bring it to payment service itself, somehow have feature flags or have some sort of header matching done there, but you have to ensure your code is updated each time and the same code is running in both versions, to ensure that the code changes, right? As we know, one is a monolith and one is a microservice, right? This is again an overhead that you have to take in. Instead, you could make use of Istio's configurations to make this happen. Like we saw with virtual service, you could set some routing rules that will, split the traffic between payments V1 and V2, right? So request routing is a good example of this. Traffic shifting is also related to what I just said, that you want to shift. You can base it on some weight, right? And when it comes to resiliency, to one thing is to test how resilient your microservices are, right? You uh, in introducing error in these cases is crucial, right? Fault injection is a way to introduce error or to delay, like introduce delay in your services to verify how your caller works, right? How is it handling it? It's good for testing these resiliency. you might want to set a standard on request timeouts across your cluster, right? While you can do it with every service that you have, like I said, if you have 50 services there, how do you ensure that these 50 services are updated and conforming to some guideline that you as an organization have set, right? Uh, it could also help with circuit breaking. Again, you can set rules on if there are failures, like three failures, then break the circuit, right? Again, you can use libraries that provide this for whichever language. Maybe order services in Go and payments is in Java. Now each one has to implement its own logic for this. And well, sometimes it's easier to have this layer take care of it, right? So that's where circuit breaking comes in. You can also use it to mirror your traffic. Might be useful for auditing purposes, security checks, um, right? And load balancing, as you know, as I said, you can specify load balancing techniques. It again, as you see the need, you can implement, customize it as you go, right? You can introduce rate limiting at this level itself. This is, again, like I said, it's between your services, right? Usually rate limiting happens at your API gateway level, maybe. But with Istio, you can introduce it between services. So in case there is order service that is suddenly having a spike, it doesn't have to bring down payment service, right? You can abstract that, you actually like the error away, right? Yeah. And like I mentioned, service discovery, again, how service discovery works is Istio specifically, it makes use of Kubernetes core DNS to discover services, and it populates its internal registry, service registry it's called, and that is updated. Like your sidecar proxies are aware of this, and that is how each sidecar proxy facilitates communication with other services in the network. Yeah, I know that was a long slide. Before I come to this, any questions, or yeah, any thoughts? You can post it on the chat. I can take it up after this, after I complete this. I just have a few more slides and see, and then we'll go to a demo. Right. Like I mentioned, there is certificate management for secure communication. Uh, so most service meshes have a built-in certificate authority, or it has support for communicating with external certificate authority. Istio has a built-in certificate authority, but you can also, like, if you have want to use an external one, you could go with that as well. So yeah, ensuring secure communication becomes slightly easier by using Istio. Again, like I mentioned, authentication and authorization are also facilitated at this layer. Right. Another major contribution that Istio does is b- uh, its metrics and logs. Right, it's able to provide metrics, logs, and distributed tracing at this layer itself. Uh, as Istio intercepts all your inbound and outbound traffic, your data plane, it's able to facilitate this. And in my experience, we have relied on this in certain circumstances, right? Istio, we had leveraged Istio's rules to configure how we want our alerting to be, how we want, the metrics to be, like what metrics to define, and how we, look at distributed tracing, right? So yeah, coming to the end of my discussion, again, that's demo pending, but should you use a service mesh, right? Like, that's probably a question that you should ask yourself. Like, maybe my talk makes it seem like, oh, I should go and implement service mesh right now, but there are nuances to it, right? uh, a service mesh helps if you have a complex architecture, and you have, when I say complex, you have like multiple microservices running that, and they are all probably in different languages and maybe spread across different environments. And in this case, maybe a single layer handling secure and reliable communication helps, right? Like I mentioned, you don't need to configure all 50 services. You can just come to this layer and define, yeah, you would have multiple objects here, but your effort is reduced in this case when it comes to such a complex architecture, right? If you have a very simple service that barely talks to like three other services, maybe Istio is something you can do without, right? um, Again, introducing such a uh, you know uh, mesh into your network, it does cause a slight bit of latency. Istio has improved on reducing the latency it introduces, but again, if you have a critical real-time service, it may not be what you want to go with, right? Again, there has to be some time and effort spent in updating and upgrading Istio. It's you like it can have a pain by itself, but again, you would need a dedicated team, or a dedicated effort, a learning curve that comes in when you're using something like Istio. Things have been easier, I feel, in the past few years, but again, as a organization or someone who is who may not be focused on the infrastructure, you may have to think about whether you want to spend on this. And another reason you could benefit from a service mesh is, leveraging observability. uh, Again, like I said, you could have each application implemented, or you could have uh, other mechanisms done, but uh, it's also very easy to leverage service mesh to, have a good observability in your system. Right. And yeah, so let's go to the demo now. So yeah, I actually have Istio already set up, and locally I'm using Kind actually, right? So I'll just walk you through the steps for now. But like I mentioned, you once you have your Kubernetes cluster up, you can use istio.ctl to install your uh, Istio into your Kubernetes cluster. And let's take a look at the config here, right? So what I'm doing is, for the purpose of a demo, I've just installed with the profile demo, but when you go to prod, you will have different configurations available. But for now, I'm just bringing in ingress and egress gateway, right? um, and yeah, again, so how does your sidecar proxy happen, right? So Istio is able to inject its sidecar proxy into a namespace, and that's what we do here. Once you have your Istio set up in your cluster and you annotate a namespace with Istio injection enabled, you will see that yeah, and if you have pods running already, you will have to, redeploy to see this happen, but you will see your sidecar proxies up, right? So let's take a look at this. So let me just do, for now, I'm just saying, yeah. So I have my pods running, right? And if you see, 2 by 2, which means there are two containers. Let me just take, huh. So if I take this, right, and I look at the container name, I can see one of it is Istio proxy, right? So that is how you can verify that it's running. uh, yeah, that ensure you check that you have your sidecar proxy running, right? Yes. So for in this case, I have my example already here locally. Like I've already applied my uh, like I've already deployed my applications. And just a second, I think. Huh. So before I go, I'm just taking an example of this. Let's say you have a product page that is served by a Python script, right? And you have three versions of review service running, and each of them are Java programs. And there's a details service that is written in Ruby. And as you can see, version 2 of reviews invokes a Node API for ratings, right? And this is the uh, honestly, like you would have come across such an architecture somewhere, right? It's very popular to use different languages, right? And this clearly shows why service mesh would help in this case, right? What we want to eventually reach is yeah, once I've deployed my service, what happens is I set up an ingress gateway, and I'll have sidecar proxies running across all my services, right? And that's what we have seen till now. Once I apply it, I do get yeah, I did get a sidecar proxy running, right? Now I'm not gonna go through setting up a gateway. All that is done. Now what I want to do is ensure that my uh, so just a second, I think. Yeah, just a minute. Let me just move it to this place. So yeah, what I want to ensure is that I'm using V1 version of all of my services. So I'll just do virtual service. I have one running. I'll just delete this for now. Mm, right. Okay. Now let's take a look at our example. Right. Now what happens is every time I refresh the page, you can see uh, sometimes, yeah, so when it's served by reviews v1, I don't see any ratings because like you saw in the diagram, we are not invoking the ratings API. um, and every time I refresh, it gets routed to randomly to reviews 2 or reviews 3, right? Again, this was because we have not defined, like it goes to least request model, right? So it chooses whatever workload is least affected. So it randomizes now. Let's
Ashmi, there is one question. Just sorry to interrupt. So, what does VS stand for the latest command you have run?
oh, what does, oh sorry, oh sorry. Oh, so I, yeah, so it stands for virtual service, right? So technically this is the whole name for it, right? So yeah, virtual service, that's what it stands for. VS is just the short code for it. I
Cool.
hope that helps.
Yeah, cool. Ashmi, I think you can. Yeah, proceed.
Sure, I'll try to not use short forms, right? But
No.
yeah, or at least define them when I use them. Yeah, sure. So going forward, so what I want to do now is I want to ensure that I'm only hitting V1 version of everything, right? And let's just take a look at one of these examples. So I'm defining a virtual service. So I'm gonna hit product page. I'm gonna call this virtual service product page. It's going to the host that I want to route to is product page the service, right? As you can see here, I have product page running here, right? Um, and what I want to say is that hit the subset B1, right? And I spoke about destination rule, right? I forgot to say that I already have this set up. So if you see destination rule, it's saying that once I'm routing to product page, what types do I have available, right? What types of, what subsets do I have, right? Um, and what labels version 1 means is that if uh, yeah, as long as the pods have version 1 annotated to it, uh, 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 match that, right? Routed to that. So in this case, if you have label version v1, it becomes subset v1. If you have pods that match v2, it uh, becomes subset v2, right? This is how you distinguish between it. So you can match it by other annotations that you feel like. For now, we are doing like we're specifying the labels that we want, right? Other labels or annotations, I mean. But yes, I think usually on labels, yeah, I'm not really sure on annotation, but whatever label you feel like. For now, we're going with version, right? um so let's get to this, right? So I will apply um, all v1, right? And now let's see what what change happened. So you can see uh, there is details, product page, ratings and reviews. We just saw product page, so let me take ratings. Oh sorry, again. Service ratings, right? And here I can see that destination rating subset b1, right? So that's applied. Now if I refresh this, I can see every time I refresh, it's served by reviews b1, right? Okay. Now let's say uh, I want to say bring in version 2 and version 3 of reviews, but I want to see how does it, I don't want to completely move my traffic yet. Maybe I set a weight of say 50% goes to reviews, 50% reviews v2, and 50% goes to v3, right? Like I said, traffic splitting, it can happen through this. So I have the reviews virtual service that now looks like this, right? It says that to subset v2, uh, pass route 50% of the traffic, right? So now let's do that. So I'll split my reviews. Let's see what happens now. So if you see, yeah, sometimes this is reviews version 3, and sometimes, yeah, it is 2. So here now it's become reviews version 2. So it randomly, like 50% actually, weight is transferred between these two. Right. Now let's say while making a deployment, like some migration, you have a fault, right? One way to check if one, like again, or this could also be used for your resiliency testing, right? So you just want to inject fault into your service. One easy way to do this is just say in case of ratings, right? Sorry, let me just make it reviews. Yeah, let me also rename it for consistency. Right. So let's say that I want to test if what happens when v2 starts failing, or maybe I just want to see now what happens, right? So in this case, what I'm saying is introduce fault where 100% of the traffic that I see, uh, you abort it with a status 500, right? What that means is your pod will not be forwarded the request. It will work as it is, but at your virtual service will reply back with a 500. So let me inject fault, right? Now let's refresh. Huh. So 100% of it is failing now, right? um, what do I do in this case now? I realize that okay, maybe like right now I'm just injecting fault, and now I can remove it, right? Another thing I can do is I want to now shift. Like I see maybe in real case, you see that v2 is failing really, and instead of a 500 you want to say 400, for whatever reason, right? Maybe you have some particular message that you want to handle, you pass that, and then you can apply this. You can say that shift all of my weight to v3 version, right? You don't really need this config, but I'm just keeping it for the sake of this demo. So now let's see. Now you can see I've completely moved to version 3, and With just a few applications, I have now recovered from an error. I have, uh, I could use these same principles to make canary deployments happen. You could shift traffic from, say, 10% to new version to 20%, and until you see that, okay, this uh, until you say like 40% of the traffic seems fine, now I can do a complete rollover to my new deployment, right? You could do that. You could do experiment based routing as well here, based on some header. I'm not shown it here, but when you route, you can match by different headers. Yeah. And yeah, so that's it for my talk. Any questions?
Yeah, feel free to ask. If you, let me just. Okay, there is something. Is there a way you can
Okay.
implement
So
this along
do
with alarm?
I? Oh,
Yeah, yeah, you
sorry.
can, you
I
can,
was
you can
unmuting
talk.
myself. As you wish. Sorry. Do I talk or
No,
would you like to read them?
no, you can ask directly. That's fine.
Okay.
Yeah.
Okay. Okay. The first one is well, I found all these amazing, really, and I was wondering when you started showing the shift between weights with the 50-50, or maybe you can put 75-25, whichever percentage you like or you determine. I was wondering if this might be used for something like an A/B testing in non-production environments, for example, so that you can see how the change that you're trying to implement will behave on a small percentage of the incoming traffic or things like that.
Yes, actually, that's one of the use cases for this. I have used it in production for the same reason. It does work well. You can route based on, say, like I said, you can match by some header, or you can introduce it. You can customize it, right? Because you're the one defining these rules. You can specify how much percentage you want to increase it by, and yes, you can do that. It could also be that you're seeing an error in one version and you want to route. Sorry, you're on mute, I think, again.
I'm on mute. Okay, thank you, Ram, for pointing it out. Okay, so um, I am aware of the term blue green. I thought that it was more related to AB, so thank you for that correction. And well, if no one else has something to ask, I have two more questions that I wrote on the chat. The second one is when you said when you forced the service to return a 500 error, for example, I was thinking that maybe you can predict outcomes to for testing purposes, relating it to my previous question. So, for example, you say, I don't know, I want to see how this part of my solution behaves, so I'm going to force the service to return an error 403 to see which is the message that I see when someone doesn't have access to a certain part of the website, for example.
Yes, that is right. In fact, you can customize it further. You could say this particular specific path is what returns an error, while the rest of it works fine, right? And another use case I've seen practically that I've used it is, say your app has been bombarded with requests and your database is taking time to recover, right? Now, what happens is, as more requests come in, even when new pods try to come up, it's not able to because your database is overwhelmed, right? In this particular case, you could inject fault at your virtual service, right? Which will now block requests to your pods, give it time to recover, right? Once it recovers, you can take away the fault so that your app continues performing. Otherwise, you will have further downtime, right? Because your database is still taking time to come up because it was overwhelmed by some spike in traffic, or maybe a DDoS attack for that matter, right? So that's also good use case for fault injection.
Right.
But yes,
Right.
it's mainly used for testing resiliency, like you mentioned.
Great. And the third question, I'm sorry for stealing the question section.
No, no, no worries,
um,
no worries, Ivan. Yeah, you can
thank you.
ask.
Anyone, there was no one else with doubt. So here I come, the third one. I was thinking, linking what I'm about to say with the previous two things. What I'm thinking right now is perhaps, let's say, lately I've been using AWS the most. So let's say that you have something that has what you just demoed, but linked on an AWS deployment. So I was thinking maybe you can link this whole thing with things like CloudWatch and link it to something like a function as a service that will help to improve the availability. So let's say that you have two services and the one fall, there's a service that is underperforming, and let's say that your auto scaling on that side is not that great, or maybe something happened that you didn't took into consideration, you didn't take into consideration, you haven't taken into consideration. So what I'm thinking is maybe as an added step, besides the auto scaling that you may have configured, to say to the alarm system that you have configured, hey, if service A, let's say that both services provide the same thing, and this approach is more of a high availability with with duplicated services besides the auto scaling. So what I wanted to ask is, let's say that service A starts receiving a lot of requests, like huge amount of requests, that it's not that wasn't considered when architecting the auto scaling part. So what I was thinking is uh, a solution that, given this scenario, would shift automatically the traffic from service B related to what to the percentage that were on the demo. So like automatically with a, I don't know, lambda function. I don't know if a lambda function can do that. I think it could, or well, a function as a service, similar function as a service, things like that. Did I lay it out right? Because it was like a lot of information, and I don't know if the question was clear.
No, I let me see if I understood. So you're asking if there is a service that has auto scaling enabled, but it's not performing as for a high spike in request, it's not able to scale in time, right? In that case, could we leverage something like a lambda function that could instead have these traffic routed to, right, which could then respond to it? Did I get that right?
Perfectly and with less words. So thank you very much for that.
Sure.
Yeah, that's what I meant, and that is the question.
Yes, sure. So, Istio, you can have something called a service entry. There's another custom resource that's available where you can specify your external services there. So now you just have to, in your route where I said reviews version 1, you will just, whatever you call your service entry, you would just have that in your route, right? Same way you split the traffic between it, give weighted, split that you want to do, that should be able to handle it. So
Awesome. Thank you so much. No further questions from me. Thank you so much for these talks that you've been doing. It's really insightful and wonderful. Yeah.
Thank you, Ivan. And yeah, any other questions? Yeah, I think yeah, that's all we have in question section. First of all, I should thank Ashwini, for accepting to speak with us, and we have kind of this Navaratri series fan, which is Ivan. Thank you so much, Ivan, for joining us every day almost, and thank you so much for the support that you have given us actually. And I think tomorrow is going to be our last Navratri celebrations day. Priyanka Sagu is going to talk about PyTest container. She has been kind of one of the few women leaders in CNCF community. She has been doing a lot of work with Kubernetes release team. So it's a kind of, we are very happy to host her tomorrow. So looking forward to seeing you all tomorrow session as well. I know it's kind of a Dasara holiday weekend kind of a thing, but we hope to see more people, and learn from things actually. Yeah. And yeah, I should thank Ram and Malu, because they have been a great support for me throughout this series. And so yeah, yeah, I think that's all I have right now. Yeah, thank you, Ashwini, for all of this, and it was very wonderful talk.
Yeah, thanks a lot. Actually, thanks for giving me this opportunity. I'm glad I'm here, and thanks for listening and asking your questions. Yeah, and Ram for your really nice comments. You know,
Thank
and
you.
Manu,
Thank you.
thanks a lot for giving me this opportunity. I enjoyed this. Yeah,
Thank you so much.
see you
Yeah.
tomorrow.
Yeah, see you all tomorrow. Thank you so much for joining us. Yeah, bye.
Bye.
Dhanyavad. Namaste. See you tomorrow.
Oh,
Yeah.
you are learning Telugu as well, Ivan. That's great.
No, just those two words because I practice yoga. So that's it. Not that
Oh, okay,
much.
okay, okay, okay.
Take care. Thank
Yeah, see
you.
you tomorrow. Bye.
Bye.
Bye.